Good morning, students. Welcome back once again. So this is our module 7, and we were studying about different types of solar energy collectors. And in the previous class, we studied about what is called a flat plate collector. Okay, and it's a different working principle, how they are working, and where they are used. Okay. Two type of solar energy collectors, in which one was a liquid running solar energy collector, and second was a air running, okay, or gas running solar energy collectors. Okay. Today we will go to concentrating type of solar energy collectors, or we call it a focusing type of solar energy collectors, in which usually focusing mirrors are used. Mirrors, okay. A mirror is something which reflects light. Okay. Here mirror will be of some circular shape. We call it a concave mirror. Okay. Something like used in a torch lamp or in a vehicle lamp, where some sort of concave reflecting mirrors are used. Similar device will be used, and in some occasion we will be also using lenses. The lens is made up of glass, and lens has a property to focus light. So in somewhere focusing principle will be used, and in some other places reflecting principle will be used. Reflection and focusing. These are the two principles which are going to be used. Okay. And we know in a concentrating type of energy collector, high intensity solar radiation is focused using such a device. It is focused to a small point. This is called point focusing, because light is focused to a single point. Where we will keep some container, we keep some enclosure, some metal enclosure, which will be filled with the fluid. Okay, fluid will get heated up, and we get either steam or boiled liquid, like that, according to our requirement. But temperature here is very high. You can go to 100 degree to 500 degrees, 600 degree, like that. You remember in flat plate collectors we hardly reach 90 degrees Celsius. 90 degrees Celsius. But here temperature is shooting up to 600 degrees Celsius. So we can get a superheated steam. Okay, this is called a superheated steam, because ordinary steam is 100 degrees Celsius. Here temperature is 500, 600 degrees Celsius, that we call as superheated steam, and which usually consists of some optical systems in the form of lenses and mirrors. We will see how a lensed system is working, and we will also see how a mirrored system is working. They have differences in working, and we will of course see in the forthcoming slides. And okay, it is clear that it is the energy is focused to a small point where the observer is kept, and temperature can rise. Even 500 is an ordinary temperature. Even in many other devices it may goes to 600, 700 degrees Celsius, like that. That much high temperature we can generate using solar radiations. And another device is same. In the previous it was point focusing. Here is a line focusing device. In a line focusing device, again, what is used? You have a trough, a cylindrical trough. Its cross section, its shape is like a parabola. So we call it a parabolic reflector. In the school class, you know parabola. So this is shape of parabola. So we call it a parabolic trough. We have rectangular trough and parabolic trough. So bottom is like that. It is usually made up of some reflecting metals. So light will focus to a focal point, okay, where your tube will be fixed. You can see inside there is a tube through which the water is running. Okay, this is the tube where it is connected. Your water running pipe will be connected here with a hose, and the pipe will run through it and will get heated up. On the other side you can take it out. Usually we can connect in the series also. Number of such a parabolic trough can be connected in series, and the heat generated will be too high, very high. Okay, so that is shown here. If the reflector is in the form of a trough with the parabolic cross section, so solar radiation is focused along a line. So the absorber is placed along the focusing line. So we have a focusing line here instead of a focal point. So we can also call it a focal axis. Okay. So point now turns into a line. So usually it's going to be length 3 meter to 5 meter depending on the requirement. Okay, it may vary, and the width may be of 1.5 meter to 2.4 meter. So dimensions vary according to the requirement. So that is an engineering design. So you can connect in series, 10 or more units, separate units. You can connect in series and you will get more energy output or steam output because you are boiling liquids, various liquids. So this way you can divide concentrating collectors either into point focusing type or line focusing type. Both are shown here using the ray diagram. For your exam purpose, this diagram is enough. Okay, if you draw this sort of diagrams for with explanation, so that is enough for exam purpose. Okay, so typically how it looks like is ray diagram. Both are given here. For a line focusing, this is how it looks like, and for a point focusing, this is how it looks like. Your boiling liquid is kept here with a tube will be there. So the tube liquid will be coming inside, and there will be output tube through which the boiled liquid will be going out. And you may wonder what is a focus actually. We mentioned many times the focus of a parabola. So suppose it is the cross of a trough, the focal point is here. This is called the focus. Okay. So when solar radiation falls over it, all the light will get reflected, and you can see in the diagram all light focus to this single point. Okay. So this is why a parabolical shaped trough is used. Instead of a circular trough, we usually use a parabolic trough where light will be focused only here. Okay. So every line you can see, as light falls over it, will get focused here. Similarly, in case of a torch lamp or a bicycle lamp headlight or a vehicle headlight, instead of light coming here, where light is going in the other way. Okay, where your lamp will be fixed here, bulb will be fixed here, and bulb reflects light and it goes in a parallel line. You must have seen a torch lamp. Okay, so in a lamp, for example, in a torch light, your bulb will be fixed here and light is going parallelly out. So that is why usually light beam coming out of a torch lamp looks very straight. Okay, beam like. That is because of the same phenomenon. But in a solar collector, light is coming in the reverse way. It is coming inside and getting focused. Okay, so principle is different, but phenomena is same. So that's the relevance of a focal point. Okay? So in case of a line focusing, you have a number of such points. So by collecting all those points, you can draw a line, and your tube can be fixed along that line. Again, when you come to line focusing, they are of 3 types. Line focusing collector, again you can subdivide into 3 types. One is parabolic trough collector, the other one is mirror strip collector, and the third one is called Fresnel lens. Okay, Fresnel lens. It's not pronounced as Fresnel. It's called Fresnel lens. Okay. So let us see the principle of these 3. Parabolic trough we have already seen. So it is shown here. Okay, this is iso-parabolic trough connected together. Okay. And this is a mirror strip. In a mirror strip, the difference is that in a parabolic shape, number of mirror pieces are pasted on a surface. You have a surface like this, parabolic surface made with some metal structure, on which number of reflecting small strips are pasted. So here it is a single unit, but here no, so many small pieces are pasted together. So it will act like a parabolic reflector. Again, it is a line type collector. And in the third one, we call it a Fresnel collector. In the previous slide, we have shown it. Okay, Fresnel lens collector. So instead of a mirror, we use a lens here. Okay, it's a lens actually. You must have seen lenses. These are planar convex lenses, on which certain shapes are made. These are called grooves. Okay, grooves. G-R-O-O-V-S. Grooves. So by this grooves, we can focus light on a point. So this is a Fresnel lens collector. Okay. So here lensing action is used, refraction is used. Here reflection was used. So again, you can have, if you consider this a block, a rectangular block. So what happens? The focusing will be along a line, and you get a huge light intensity along a line, where you can keep your pipe. Okay. So in parabolic trough, already we discussed enough. Same thing is shown here. It's a huge farm, okay, solar energy harvesting farm, which is usually used for power generation. You can see it's a very large area. So industrial, it has so many industrial applications actually. It does not exist mere in theory. It is practically established in many countries. Even in our country, we have so many such industrial plants where solar energy is harvested, especially in Thar desert in Rajasthan. We have such arrangements. When you come to mirror strip, it is shown here. Large number of metal strips are placed on a curved surface to form a parabolic trough surface. Same thing as shown in the photograph. Focal point will be along a line, so you can keep your pipes along the focal point. So I hope the idea of focal point and the focal line is clear to you. When you extend the points, you get a line. So here, what is the advantage? You can easily remove it. Suppose you want to establish a temporary setup, you can bring a small strips in vehicles and install it. But instead of that, if you have large mirrors, then it is very difficult to transportation. Okay. So people prefer to have strips. If you want to arrange the system on a top building or at any such remote places, it is better to have stripped devices instead of having a whole mirror setup. Mirror may get easily broken. So we say that it is easy to install at a place. Okay, you can easily mount it, you can easily dismount it, you can easily assemble it and deassemble it. So there are so many such advantages. And the third category was line focusing Fresnel lens collector. So it is a special type of lens with certain grooves on the curved surface. You can see it is here. Due to lensing action of the device, energy gets focused along a line. Okay, so actually it's a two-dimensional picture. If you actually imagine a three-dimensional picture, it will be a block like a rectangular with length, enough length and breadth. So it is actually the focal here. The focal point is not a point actually, it's a line. Okay. Along a line, you get focus. Suppose you keep a paper over it, paper will be burned along a line. A line you can see, burning line, not a point. But it has one demerit, that is it can be easily broken. You cannot transport from one place to another. You cannot easily mount and dismount. Once fixed at a place, it is fixed. You cannot change the place. So because heavy lenses are used, that is another disadvantage. Still it has many other merits, widely used in different solar energy harvesting places. Okay. So this is all about different kind of line focusing devices, and you have so many advantages for a focusing collectors compared to non-focusing collectors that we studied in box type structures. So in focusing collectors, these are some of the advantages. Insulation intensity is higher, means the energy focused at the place is much higher because we are focusing, and working fluid can attain higher temperature. I already mentioned it, 600, 700 degrees like that. Energy loss per unit area is small. Why it is small? Because energy is focused in a small area, it is enclosed, so energy cannot liberate out. Okay. So reflecting surfaces require less material. That is also another advantage. Okay. Let's come to another important application of this concentrating devices. Okay, this is purely based on concentrating device. The device is called a solar power tower. Solar power tower is used for electricity generation. It's a ray diagram of a solar power tower. Let us see how this is working. This is almost similar to a thermal power plant. But the only difference is that thermal energy is given through solar rays, not by burning fuel or any other coal like that. Okay, let's see how it is working. So these are the reflectors. Okay, focusing reflectors, concentrating reflectors. we call it heliostat. The radiation gets focused to a point, which is called a receiver, which contains some fluid, not necessarily water. Okay, some other fluids are used, some organic fluids are used, and you can see as the radiation falls over it, the fluid gets steam. They get boiled up. They become superheated vapor. Not necessarily steam. Steam is for water. Maybe some other vapor, but in high pressure state. This high pressured vapor is brought here and it is used to run a turbine. Understand? So turbine leads to the rotation of the generator, and generator subsequently generates. Very simple working principle, but its technology is highly complex. You can see some tower. This is a real solar power tower. It's called solar power tower. Real photograph. Working very profitably in Spain. Okay, Spain, a place called Andalusia in Spain, where you can see lot of heliostats. These are mirrors. It is focusing light to this place. Here liquid is kept, whichever liquid is being boiled, and subsequently this liquid is used to rotate a turbine. You can see a plant here at the bottom. It is a very long tower. It is kept high because temperature is too high, so we should not create any damage to the surroundings. That is why it is kept high. And the generating station is here at the bottom. You can see it's an old mirror setup. Okay, so this is another plant in USA, California. Again, you can see heliostat reflectors. They are reflecting the light throughout the day, and it is focused here, and you can see the fluid is here kept, and it's a generator station. Okay, turbines and all are kept here, which is used to generate electricity. So these are some typical example of solar power tower. So solar power tower uses a collection of tracking reflectors, heliostats. Why it is called heliostats, we will see shortly. Reasons to call it like that. But they are reflectors to concentrate light on a central receiver at the top of a tower. Okay, such power towers are more cost effective. They are highly energy efficient, because cost effective means we don't have to spend any fuel. Okay, like energy is coming from space, so it don't have any cost. Only we need some reflectors, and they are long lasting. Once installed. No further expense is there. That is another advantage. They are highly energy efficient. We can act like a normal thermal power plant or a nuclear power plant. We can have enough energy generation, provided that sufficient solar energy is available throughout the year. Okay, throughout the year, solar energy must be available. Okay, so these are some of the advantages that we have seen, and the concept of heliostat is very important. These are a typical single unit of heliostat. There may be such thousands and thousands of heliostat in a solar power plant. It will be distributed over an area on the ground, and each mirror is known as heliostat. Why it is called heliostat? Because it is always focused directed towards direct sunbeam, direct radiation. So sun is always moving from morning to evening. It is moving. So accordingly, this mirror also should be moved from morning to evening. So it is always static towards the incoming radiation. That is why it is called heliostat. Helium means sun, basically. So something always static towards the sun, which is called heliostat. That is how the meaning comes, heliostat. So heliostat can be separately controlled to track the sun rays and direct the reflected radiation towards sun receiver. Okay, always they have to move because sun is moving, so heliostat also move, and should always focus the light towards the tower where your fluid is kept. Okay, it should always focus the light towards the fluid. So it must move from morning to evening. It is usually computer controlled. Okay, now human beings are there, computer controlled, so it will go on running by its own. It's an automated system basically. It will run on from morning to evening, uninterrupted. Okay. So this is used in solar power towers for electricity generation. So this is a very effective machinery to generate electricity without any pollution, no pollution, no noise, nothing. Okay, so these are the content of this module. Now we have a simple assignment here. Okay, give the working principle of a line focusing solar analytical. Very simple question is given. You write the answer. You can search in any books or in any website. You get the answer, but you confine your answer to a single A4 sheet. That is enough. Thank you all.